Google DeepMind has unveiled its most advanced AI models for robotics, introducing systems that can think through complex tasks before taking action and search the web for real-time information to solve problems. The two new models, Gemini Robotics 1.5 and Gemini Robotics ER 1.5, represent a significant leap forward in creating versatile robots that can adapt to new environments without extensive reprogramming, according to Carolina Parada, head of robotics at Google DeepMind. These models address fundamental limitations of traditional robotics by enabling adaptive behavior and contextual understanding, moving beyond the specialized, single-task robots that have dominated the industry until now. The breakthrough centers on Gemini Robotics ER 1.5, which DeepMind describes as the first robotics AI capable of simulated reasoning, similar to modern text-based chatbots. The ER stands for embodied reasoning, allowing robots to plan multiple steps ahead before executing physical actions. During demonstrations, researchers showed a robot successfully sorting recyclables after being asked to categorize waste according to local regulations. The robot identified the researchers' San Francisco location, searched for local recycling rules online, and correctly sorted the items. In another test, when asked to pack for a London trip, the robot searched weather forecasts and included appropriate items like a beanie. This represents a fundamental shift from pre-programmed behaviors to adaptive context-aware decision-making. Contemporary robots are highly specialized and challenging to implement, frequently necessitating months to deploy a single unit designed for a singular task, stated Carolina Parada, head of robotics at Google DeepMind. The new generative AI approach enables robots to tackle entirely new scenarios without reprogramming, addressing fundamental limitations of traditional robotics. Where traditional systems require months of deployment time for specialized tasks, the Gemini Robotics models enable instant adaptation to new scenarios. This transforms robotics from single-task specialization to multi-purpose capability, replacing environment-specific programming with contextual understanding and expanding limited functionality through web search and reasoning capabilities. The system operates through a sophisticated two-model approach that separates reasoning from action execution. Gemini Robotics ER 1.5 handles reasoning and planning, including web search, multi-step planning, and contextual understanding. This model is now available to developers through the Gemini API. Gemini Robotics 1.5 handles action execution, including physical movement, task execution, and real-world interaction. Access to this action model remains limited to selected partners. This separation allows for specialized optimization of each function while maintaining seamless integration between planning and execution. The architecture represents a significant advancement in robotics AI, enabling more sophisticated behaviors than previously possible with unified models. A remarkable capability of the Gemini robotics system is its cross-platform compatibility. Tasks learned on one robot can transfer to completely different platforms, including humanoid robots. Google DeepMind demonstrated this capability by showing how tasks trained on the two-armed Aloha Q robot seamlessly translated to both the Franka robotic arm and the Aptrononics humanoid robot Apollo. This cross-platform compatibility could accelerate robotics development across industries by addressing major challenges, including accelerated development across different robot platforms, reduced training time for new applications, standardized AI behaviors across diverse hardware, and scalable deployment of robotic solutions. This breakthrough could significantly reduce the time and cost required to deploy robotic systems in new environments. The Gemini Robotics announcement builds on DeepMind's broader robotics initiatives, positioning Google as a leader in AI-driven automation. Recent developments in Google's robotics ecosystem include RoboBallet, an AI system unveiled earlier this month that coordinates up to 8 manufacturing robots with 25% better efficiency than traditional methods. The company has also expanded API access, making the Gemini Robotics ER 1.5 model available to developers through the Gemini API. Strategic industry partnerships with robotics manufacturers and research institutions, along with integration of advances from Google's broader AI research efforts, create a comprehensive ecosystem that enables rapid advancement through shared learning and component reuse. This ecosystem approach represents Google's strategic commitment to advancing robotics through AI innovation. The Gemini Robotics models represent a paradigm shift in how robots interact with the world, moving from pre-programmed specialists to adaptive generalists. Potential applications span multiple industries, including manufacturing, where robots could adapt to production line changes without reprogramming, logistics, with warehouse robots that understand changing inventory requirements, healthcare, with assistive robots that adapt to individual patient needs, and home assistance, with robots that understand contextual household tasks. As these systems continue to evolve, they promise to transform industries by creating robots that can truly understand and adapt to dynamic real-world environments. This moves us closer to the long-envisioned future of general-purpose robotics that can flexibly assist humans across diverse scenarios and environments.